Now we're going to talk about electrical systems in a home. Look, free electricity. All right, in this presentation, you're going to learn about meters, paneling, wiring, receptacles, boxes, all this type of equipment. So make sure you are ready in your engineering notebook and let's go. First thing is the legend. So I want you to make a note of this electrical legend, and mainly the things that I want you to mark down here are duplex outlet. This is a typical receptacle outlet in the wall. It's two lines with a circle around it. Two lines with a circle around it. A ground fault interrupter outlet. That is called a GFCI or GFI. It's two lines with a circle around it and then the letters GFI or GFCI. A single pole switch. This is just a switch on the wall. It's just an S with a line straight through it, almost like a single dollar sign. This line isn't showing all the way through it, but that's typically what you'll see. And then a three-way switch is the same thing, but it has a 3 next to it. There are also four-way switches, but they're less common. Ceiling fan, ceiling light, these are things that are pretty obvious, but these duplex and single pole switches are going to be really important that you know what those symbols actually look like. So as long as you have these four, I think you are in good shape. All right, now let me give you background information here. Electricity is supplied to a building via a service drop. This is just 3 gigantic wires. 2 of them are carrying 120 volts. One is neutral. And building electrical circuits is powered by the difference between any 2 wires. Right now, for all of your outlets in the walls, receptacles in the walls, it's 120 volts for most appliances. It is 240 volts for things like your dryer and for your range, but those are really the only items that use 240 volts. We now have things like electric car plugins and things in garages that are 240 volts, and sometimes they'll call it 220 or 110, but those are still referencing those values. Power is the rate at which energy is used. It's measured in watts. I'm not going to have you actually do any of these calculations here, so you don't see a pencil icon here, but just kind of going through some background stuff from your science class. So here's what I want you to make a note of. This is about the main panel. The main panel, and we have one of these in room 112 against the wall. You'll see one of these circuit breakers here. This is the power that's supplied from the meter. It distributes the power to the entire building. The main breaker allows all the power in the entire building to be switched off. That is this giant switch, usually at the top, and it turns off the entire building. These smaller individual circuits will allow individual circuits to be switched on and off. If you need to do something to work on a circuit, that's what you use. So this question, what do you switch off if you need to work on one circuit in your house? Let's say you have a receptacle that no longer works and you need to replace it. Do you turn the power off for the entire house? No. That would be crazy because you lose power to everything and it's unnecessary. So you find the circuit, that breaker, that is the one that controls that receptacle, and that is the one that you turn off. So please make a note of that. That is an important piece that I want you to understand. You don't need to power the entire house off to work on one thing. Sometimes that can disrupt some of your electronic appliances and throw them out of whack. So it's just best to find the one that is tied to that particular receptacle or switch or fan or whatever it is that you're replacing. All right, as far as building wiring, you have these cables. They're typically black and white, and then you have a neutral one. Sometimes the neutral one is not covered in anything. In fact, most often it's not. It's just this copper wire that sticks out. So you have black, white, and then a copper wire. That is called a 2-wire circuit. And 2-wire, that's where you would just have a switch that turns a light on and off. And it's about as simple as that. Electricity is fed in the hot, it returns to the neutral. The ground wire is a safe path if there's a short so it doesn't go through you. All right, let's take a look at the receptacles. This is the common way you power things. You have the neutral slot. This is that white wire. The hot one is the small one. That's the black wire. And then the ground, that neutral, that copper wire, or sometimes it's green, is this bottom plug down here. A ground fault circuit interrupter, a GFCI receptacle, is something that's required in wet locations. You have to have those in kitchens and bathrooms. And this is not actually a real photo. These people would be dead. And what it does is if there is let's say water gets into it, then this little button pops instantly instead of having it travel all the way to the panel and then having that circuit breaker trip. So it cuts the circuit instantly, so you don't have any risk of getting electrocuted. If you have a GFCI receptacle here, and then you put another receptacle in line next to that one, and another one in line next to that one, as long as this is the one that's closest to the circuit breaker panel, then this one will actually trip if any one of these receives some kind of a like water or something like that. So one GFCI can protect everything on that string of receptacles. So you might see one of these right next to your kitchen sink in your house or your bathroom, but the rest of them might not have this little button, this test reset button. They're all still protected by this though. As long as there's one of these in the string in the line of receptacles, then they're all protected. So you can have a circuit that has many receptacles, and this one is protecting all of them. All right, now we have a single pole electric switch. This is just a switch that controls one light. It could control many lights. You could have a switch that has a light here, another light, another light. So one switch turns on like 4 lights in your living room or something like that. And the switch looks like this. When the switch is on, then this connects the circuit. When it's off, it doesn't. So make sure you note this is what a single pole electrical switch does, and it just controls the light, turns it on and off. Your other scenario, and there's just another picture of what it might look like for wiring purposes. Your other scenario is a 3-way electrical switch. This one, you can have a switch from 2 locations. So we have a switch right here. It can turn this light on. And then you have another switch on the other side of maybe the living room. And by code, it's required you have one of these at the top and bottom of stairs. So you have stairs. You're already aware of this. You have a light switch at the top of the stairs, one at the bottom of the stairs. So no matter what you do, it will switch it on. This is required for stairways, and it's a nice feature to have in like a kitchen or a living room because you have multiple ways you're going to turn it on or off. Most bedrooms do not have this because you only have one entrance and exit to the bedroom. Hallways, you oftentimes will have these. So you have a switch, it turns on all the lights. You could have many lights. You could have, 3 or 4 in a hallway here, and then you'll have another switch on the other end, and both of those switches can then operate this. So in order to do this, you can't just use a black and a white wire. There has to be a third wire in there, and it's a red wire. So that's called a 3-way wire instead of a 2-way wire, and that's why we're saying in this next bullet, 3-way wiring is necessary if you're connecting a ceiling light and a fan. You don't necessarily have to have a 3-way switch. You could have 2 switches, but you have to have 3-way wiring. So you're going to have a wire that is your black wire that goes maybe to the fan, and the red wire in that goes to the light, and the white wire returns both of them back to the switch. So there's 2 different scenarios here. One is 3-way switches that control from 2 locations. Another way is 3-way wiring that will connect a ceiling light and fan. So that is getting a little bit deep into electrical, but if you decide that that's something you're interested in and you want to learn more about it, we can get some wiring in if you finish this unit early, and I can show you how you actually wire these things up. All right, as far as electrical codes, they are all having to reference the International Residential Code. There are national codes that we always need to follow just for safety reasons. Electrical stuff cannot be done if you do not know what you're doing. It's a very dangerous thing to just kind of guess. Here is a sample of what an electrical plan might look like, and you can see here we have this S3. That means a 3-way switch. There's not a line through this one. Sometimes there are not lines through, so it's just different symbols. And then you have all your duplex receptacles. There's 2 lines with a circle. So if we take a look at a couple of these plans, you'll notice in the hallway we have a 3-way switch, we have a light, and we have the other 3-way switch. In bedrooms, there's only one switch to a light, one switch to a light. In this bedroom, there is a switch to the light and another switch to the fan, but this is one set of 3-way wiring. This is a black and red wire with a white returning it. So it's actually one bundle of wires, but in that bundle there's 3 wires. A black would go to the fan, the red would go to the light, or it could be the other way around, and the white returns both of the current back to the wall. We have a switch right here that is controlling, which is kind of funny here. This would be not super typical, but it's controlling all of these outlets. In fact, you would never really want that, but a lot of times you'll do electrical systems where a switch controls maybe one receptacle on a wall, and the other ones are always hot, which means they're always on. Here you have a switch controlling this half bathroom light, and you have a GFCI receptacle because it's a bathroom. Another GFCI in the bathroom. Let's look up here. In the kitchen you have this GFCI. They do not all have to be GFCI though. One of them, if this is the first one in line that goes to the main breaker, if this is GFCI, all of these other ones are also protected by that ground fault circuit interrupter, GFCI. So you can see so on and so on. We have a couple other 3-way switches controlling these lights. Most likely you'd have more than one light in a living room. That would be a really very low lit living room. So if you're going to do your electrical, you probably want to have multiple. You are going to create one of these electrical plans. So this can be a really nice reference if you want to come back to this presentation and pause this. We also have a screenshot of this in another spot in the assignment. So electrical conservation is always going to be something that is important. People are installing time switches. They're using energy efficient appliances, energy efficient lighting, recessed lighting that are rated for insulation to help improve your insulation. So energy conservation, always an important piece for people in their design. All right, so why use lights when you can use the sun? There is this term, I want you to write this down. That's why we have our pencil here. It's called fenestration. Fenestration is the arrangement of windows for maximum solar gain. So that is allowing maximum light to come in without making too much energy loss through windows. Remember from our insulation unit, when you have a lot of windows, you actually, those are the least efficient for energy insulation. And so we don't want to have too many windows, but we want to have them strategically placed so that we're getting light when we want it. So which side should be facing south in this scenario? South in the northern hemisphere is getting the most light in most parts of the day. So I would probably suggest that this side right here, this wall is facing south, because we have all of these all these windows here. So we're getting a lot of natural light in this living room. It's going to spill over into the kitchen. And if this is south, that means that this bottom edge is east. And that's where my kitchen is, which is really nice to have natural light in the morning when I'm making breakfast in the kitchen. So this would be a really convenient layout, having east on this side for morning light, south on this side for a lot of light throughout the day. And then it doesn't really matter here on the north and west. The west side is going to be a little bit warmer. And so that's just kind of how we have that. But as far as the south and east side, that really helps. So when you are working on your plan, you're going to need to dictate which side of your house is the south side, which side is the west, which side is the east. West is where you're going to get late afternoon sun, and all those things. So keep that in mind when you're thinking about your design. And that is it for this particular lesson. Go on to the assignment now, and you get to design your own electrical plan.